Alright, this is day 4, quadratic formula within the unit 2, quadratic equations. What I'm going to do first is I'm actually just going to solve a general quadratic equation using completing the square that you saw yesterday. So any value A, B, or C. At the end of this, what we're going to have is quadratic formulas where this is going. My first step is to kick the constant to the other side by subtracting it. So I'll have ax squared plus bx equal to negative c. Then I'll divide everything by a, so my leading coefficient will be 1. When I do that, I'll have 1x squared plus b over ax, leave a little space there to complete the square, equals negative c over a. Now what I'm going to do is actually complete the square, and I'll do that by doing b over 2 squared. My value of b is actually b over a. So if I have b over a divided by 2 squared, this is from completing the square yesterday, this would be b over 2a, and that will be b squared over 4a squared is what that will be after I square everything. So I'll add that to both sides. Now what I'm going to do is go ahead and factor that left side. It will be x plus b over 2a squared equals, and on this right hand side, what I'm going to do is I'm going to multiply this by 4a on top and bottom so that I can combine my fractions. So what it will look like is it will now be over 4a, and it will actually be b squared minus 4ac. Some of you might remember that from the quadratic formula. We'll see. Let's plus or minus the root on both sides. So x plus b over 2a equals the plus or minus root of everything over here. On the numerator, I'm not going to be able to do anything to that. I can actually take the square root of the denominator and write it as plus or minus, and I'll have the numerator be the square root of b squared minus 4ac still. But the denominator, the square root of 4a, is simply, this was a 4a squared through here. The square root of 4a squared is actually a 2a. So I miswrote that earlier from the previous denominator. That should have been 4a squared right there, trickling down through here. So square root of 4a squared is 2a. Last step is to subtract the b over 2a from both sides. So x equals negative b over 2a plus or minus the square root of b squared minus 4ac over 2a. Since both those have a denominator of 2a, we can actually write it simply as negative b plus or minus the square root of b squared minus 4ac over 2a, and that's known as the quadratic formula. That's what we'll use today. It can be used to solve any quadratic equation you encounter, and it comes by completing the square. That's an important thing to realize. So we're going to solve this equation by using quadratic formula. You can see the quadratic formula written again up here. They actually give you an example as well, but I'm going to be using that in this situation. It is not in standard form yet, so that's actually going to be my first step, is to get it in standard form by subtracting 33 from both sides. And now I can actually work with quadratic formula. So the value of a is 1, the value of b is negative 8, the value of c is negative 33. All I got to do is just insert those values up there and simplify. So it will look like x equals negative b, negative 8, plus or minus the square root, b squared minus 4ac, so negative 8 squared minus 4ac. And a is 1, and c is negative 33. You can tell I'm using parentheses when I'm inserting these values for a, b, and c, and that's really important, because if I don't put parentheses around negative 8 before I square it, you'll get negative 64 instead of positive. It makes a big difference. 2a is on the denominator, so 2 times 1. Now let's simplify everything down as much as I possibly can. Negative 8 is positive 8, plus or minus the square root. This will be 64. Negative 4 times 1 is negative 4. Negative 4 times negative 133 is positive 132. And 2 times 1 on the denominator gives us 2. I can add what's in the square root right now. What you never want to do is you never want to take the square root of 64 right here, because the addition will come before square rooting, because there's implied parentheses around the 64 plus 132. That's where a lot of people make a mistake. So when I add 64 and 132, I get 196. And it's always worth seeing if that is a perfect square, and in fact it is. The square root of 196 is simply 14. So 8 plus or minus 14 over 2. This will actually give me two rational answers. One of my rational answers will come from doing 8 plus 14 and then dividing it by 2, and the other one from doing 8 minus 14, dividing it by 2. Doing the 8 plus 14, I'll have 22 divided by 2, and that is 11. X equals 11, or over here, 8 minus 14 is negative 6. Divide that by 2, I get x equal negative 3, and there's my two answers for the quadratic equation. Alright, now moving right along, taking a look at x squared minus 34x plus 289 equals 0, just setting it up using the formula that was on the previous screen. X equals negative b is negative 34 plus or minus the square root of negative 34 squared minus 4 times a is 1 times c is 289. We're going to have enormous numbers here, but that's alright. All over 2 times a. Now I'm going to have x is equal to positive 34 plus or minus the square root. When I do negative 34 squared, I get 1,156. Then I'll do my negative 4 times 1, that's negative 4, and negative 4 times 289 comes out to 1,156, so minus 1,156 over 2 times 1 is 2. Alright, what's going to happen here? This is going to go to 0. When it does that, the square root of 0 is in fact just 0. And whether I add 0 to 34 or minus 0 to 34, there's no difference there. I'm actually only going to have one unique root here, 34 divided by 2, which is 17. But remember, a while back I said there's always two answers to any quadratic equation, and there is here. 17 is what's referred to as a double root. And that's my answer, x equals 17. Whenever you have the square root of 0 through the quadratic formula, that's when double roots are happening. Alright, you'll see that sometimes another way might be better suited for a problem. For instance, if I was looking at this problem doing it, I would do it by completing the square because I think it's going to be quicker than quadratic formula. But today is all about quadratic formula, so let's just keep that ball rolling. I have x equals negative b, which is negative 6, plus or minus the square root, b squared, so negative 6 squared, minus 4 times, my a value is still 1 on this one, times c is 2, all over 2 times a. And we'll see what happens on this one. So x equals negative 6 is positive 6, plus or minus the square root. 6 squared is 36, minus 4 times 1 times 2 is 8, over 2 times 1 is 2. 36 minus 8 is 28. Now, it looks like we've kind of hit a wall because you can't square root 28. It's not a rational number, but you can simplify it. So going back to our second day in this unit, what's going to happen there is if you square root 28, let's divide out the 4, that's a perfect square. That'll divide into it 7 times. The square root of 4 is 2, so 2 root 7. That's what I'm actually going to replace this with. So x equals 6 plus or minus 2 root 7 over 2. And now, if I look at all three parts of my fraction, I can actually divide out a common factor of 2 from everything. So it's going to become 3 plus or minus 1 root 7 over 1. And since it's over 1, I don't need to write that denominator, so it's just going to be 3 plus or minus 1 root 7. And there's my final answer. So you're seeing something slightly different happen through each of these problems, and you will again on this one. So let's go ahead and get it in standard form. So I'm going to have x squared minus 6x, subtracting that 6x over to the left, plus 13 equal to 0. And now I'll actually use quadratic formula yet again. But again, a different thing's going to happen here. You're actually going to end up with an imaginary root, so I wanted you to actually see what that looked like. Negative b plus or minus the square root of b squared minus 4ac. I think y'all are probably getting used to setting that up. You will have to memorize this for your quizzes and tests. Alright, all over 2a. And now we'll just start the process of simplifying that down, very similar to what happened on the last one. The 4 times 1 times 13 ends up being 52, so minus 52 over 2 times 1 is 2. Now when you do 36 and you subtract away 52, you end up getting negative 12. Or excuse me, no, negative 16. Sorry about that. Alright, there's my imaginary root happening because of the root of a negative. So I'm going to pull out an I, and also the square root of 16 is 4, so I'm going to have this turn into 6 plus or minus 4i over 2. And that can actually reduce by dividing out of 2. X equals 3 plus or minus 2i. And that's as far as you can take that. You can't combine 3 and 2i. So my two answers are imaginary, 3 plus 2i, and the other one is 3 minus 2i. One or the other, maybe both. Alright, really quick, talking about discriminant. The discriminant is simply the b squared minus 4ac value, the value that was underneath the root. That value alone tells you a lot about what kind of solutions you're going to experience. If it's positive, greater than 0, and it's a perfect square, your roots are going to be real and they're going to be rational. Now if it's positive, but it's not a perfect square, they'll still be real roots, but they will be irrational. And this is what your graph would look like right here, where it's the x-axis in 2 locations. Okay, now what if it equals 0? We saw a situation of that. That's where you have the double root happen. So there's one unique real root, but it is a double root, so there's 2 answers there. Just happens to be the same answer both times. And lastly, if it's negative, if b squared minus 4ac is negative, you'll have 2 complex roots, the imaginary roots. You'll see a I in your answer. This is where it does not intersect the x-axis at all. I forgot to mention on double root, that's where your vertex is actually lying on the x-axis. So without even really doing any work on a problem like number 5, I can actually figure out a lot of information just by doing the b squared minus 4ac. Alright, so if I actually do the discriminant, that tells me a whole lot about the problem, because if I do 2 squared minus 4 times 1 times 7 and evaluate that, that is 4 minus 28, negative 24. Now, right off the bat, I know there are 2 unique roots, but since the discriminant is negative, I know they're imaginary. They are 2 complex roots. And that's how discriminant's used. Sometimes on a situation, you just want to know how many roots there are and what kind of roots they would be. And that's actually good enough for the problem, depending on the context of the situation. But that's how it's done. The only other thing I've got to talk about today is just what to use where. You can see this enormous, elaborate chart that was developed by the book, talking about what method of solving to use where. We learned about graphing in Unit 1. It's great for rational answers. Factoring is great for rational answers as well. Square root property, that's great whenever you don't have a bx term, or if it's already set and ready to go with a perfect square trinomial. And then these last 2 methods. These last 2 methods are going to work for every single equation that you find, because previously these won't handle imaginary roots. They won't handle, these 2 up here won't handle irrational roots well at all, but these 2 will. And they will also work for the rational answers as well. So if you know nothing but quadratic formula, that's actually a really good thing to know. If you can handle quadratic formula, you'll be just fine for any quadratic equation I throw at you. Only problem is on the test I will have a specific problem where I'm looking for the completing the square process. And you might not have as much understanding about other things coming up. You do want to be able to factor moving forward into Math 3 and pre-calculus. All right, so again, quadratic formula, great tool. Completing the square, good for when it's easy. You can see an example of when it's easy to use completing the square. But both of these are great methods. That's all I got for you today. Thank you.